So our next window function that we're going to dive deep in, and one that we're very familiar with at this point because we've solved so many issues with it, last value. Return the value evaluated against the last row within its partition, the last value. So how does that work? Well, what if I want to know how my price compares to the item with the highest price in the same category? Well, let's look at what that would be like. And so over here, we can see we're doing the same select with product ID, price, category, and now we're using last value instead. And we're doing it over, and we're saying, hey, I want the last price. But you can see here, just like we did with first value, but we figured out it was unnecessary. We're doing a partition change. We're going to change the framing to be range between unbounded preceding and unbounded following. So we're still partitioning by category and we're still ordering by price, but we're going to change the frame to be unbounded preceding and unbounded following. So let's see what happens there. And so if we did last value against the price over the partition category, and we did order by price, and we said most expensive, because we need to name it right. And then we said, hey, okay, so I have this. What's going to happen, and we saw this in the previous video, is we're taking into account the previous row and the current row. So we're always going to choose the current row. So we need to go beyond the current row. And so we say range between unbounded preceding and unbounded following. And what that gives us is the ability to get the highest price in that category because we're taking into account the entire partition, not just everything before and the current row. So we're getting the actual most expensive product in that category. And unlike with the cheapest product in the category, which seemed to be $9.99 in every category, well, it seems to be $29.99 in every category here as well. Interestingly enough, there isn't much variety in pricing in this code base. So the highest price is $29.99, the lowest price is $9.99. But with that being said, what we know is that we can get the highest price. But just like with first value, is this the most efficient way to do it? No, we had to write so much code just to get this done. So maybe we could do something like max. And if we run max, we're still going to get the same value because we're still running it against a partition by category. So more efficient, less efficient ways, but whatever way works for you to get the right answer. And so with that, let's jump into the explanation of what happened here. And so if we were to look at what exactly happened here, just like with first value, we're selecting from products, we're getting product ID, price, category, and we're trying to get the most expensive thing in the category. And so to view it the most complex way, if we didn't use max, what we would be doing is we'll be sorting by category. And then inside of that category, we're sorting by price. And then we're grabbing the very last value in that category for that price. So because we're sorting inside. And the framing has something to do with this because without the framing, we wouldn't be grabbing the exact last value of the range, right? So it becomes this mental model of like, how is my window frame operating? What exactly is my window frame doing? And I find these high-level visualizations to really help understand what exactly is going on here. So try to apply these mental models when building a query with a window function, and it may help you solve for certain problems. Now let's dive into something a bit more fun, like an aggregate function that does sum, for instance.